In this lesson, we'll approximate one of the blades. Let me unhide all auxiliary elements. Then, in the tree, I'll hide the surfaces that have already been used and are no longer needed. Now we'll start working with the most interesting part of our impeller. Let's unhide the polygonal object. If we set an orthogonal view, we'll see that this outline can be approximately defined using a toroidal surface. Of course, we won't get an exact result since it's not actually a torus. For a more precise approximation, we'd need to create additional surfaces that describe the geometry in greater detail. But we'll accept this inaccuracy in order to speed up the lesson. Start the surface adjustment command. Select the surface type torus. Select the triangles on the end faces of every second blade. Let me adjust the brush size. Don't forget that you can exclude incorrectly selected triangles using the switch in the Parameters panel. This will be enough. Confirm. Align the torus with the y-axis of the local coordinate system. Make them coaxial and round the torus radii to 22 and 43. Confirm the object creation. Let me rename it in the tree to an surface of blades. Change the torus color and make it transparent. Confirm. Let's hide the torus for now. I'll select a blade that's less distorted than the others. This one, for example. We'll approximate its curved surface. Start the surface adjustment command, but this time select the surface type Spline surface. Select the triangles, as many as possible, but be careful to avoid the triangles on the blade fillets. This can distort the approximated surfaces. We'll add the fillets at the final stage of the modeling. Confirm the selection. The surface preview appears. Here we can adjust anything. Just confirm. Let's analyze the new surfaces. Click Deviation Analysis. Select the surface and the polygonal object. You can see that the maximum and minimum deviations are located beyond the blade face. Most of the surface falls near the center of the deviation range. Let's narrow the range to -0.1 to 0.1. It looks pretty good too. The largest deviations are at the blade base, but that's where the fillet is, so it's okay. I'll stop the command. If your result looks different and you've obtained large deviations, try approximating the surface again, this time including more triangles and avoiding distorted areas.